ecological heroes of mine, so I can't tell you how grateful I am for you to be joining us today. I'm flabbergasted. I'm excited. So for those of you who don't know who Nikita Zimov is, Nikita, like his father Sergei Zimov, are ecologists who have lived in Siberia and studied permafrost their entire lives. They've witnessed vast existential changes occurring in the region they grew up in. Lakes spewing out methane, land areas collapsing, coastal areas melting away. Though the challenges might seem impossible for them, they had an idea how to do something about it. From their studies with ecosystem restoration, they noticed that areas with animals grazed and trampled were over 20 degrees Celsius or colder than areas where there were none. Also, the areas where grasses came back stabilized the ground, while the areas with tree roots and mosses were collapsing. From their theories and experiments came a plan. To stop the permafrost from melting, they needed to restore the Pleistocene-era ecosystem and bring back the large herds of mammals which were hunted out thousands of years ago. The work at Pleistocene Park has been chronicled in scientific journals, magazines like Scientific American and the Smithsonian, and in documentaries and shows like Vice. I'm excited to bring Nikita Zimov on because he's an example of what a small team of people can do when they are motivated by a great cause. In Nikita's case, he is dedicated to rewilding the Siberian tundra, and the world owes him a great debt of gratitude for his work. So here's Nikita Zimov of Pleistocene Park, ecological champion, awesome dude. Thanks for coming on, Nikita.
Yeah, thank you. Too much pressure on me now. Thank you very much. Thanks for joining. I hope it will be a pleasure for you to listen. So I will give you a kind of introduction of where we are, what we do, and then go slowly to the Pleistocene Park and our idea, and not only about the park we do, but also like the scientific background for the work. So, okay, let's not waste your time. So our research station, which was founded by my father, is located in the far north of Russia, so it's not very far from the Arctic coast. It's in the Kalma River lowland, so you see here on the map, it's indicated as Northeast Scientific Station, and the Pleistocene Park is beneath. What we have, that's the image taken from the nearest mountain. You can see there is our station up in the cliff right there. It's quite a spectacular and nice place, especially in the summer. So that's an image of our station from the airplane, then down from the river. So you can see our barge, the most romantic place on earth. Then it's our main headquarters during the summer. It was once used as a TV station in the past. Now it has different laboratories, living quarters, so the conference hall. That's how it all look. That's another winter shot. So I will go through some slides first. Then that's a conference hall. That's our barge. In case we have lots of visitors in the summer, the barge can host up to 20 people, and it can be taken to various places, like this spectacular place called Duvana Yar. That's a place where the permafrost is exposed and kind of eroded, and you can do lots of research and interesting things there. Then that's our airplane, which we did research on. That's our so-called baby mammoth. So that's the little vehicles we have in the park, which is used, sometimes can be used to knock down little trees. Then it's also like some group of scientists we are taking to excursion to the park. Some other interesting slides, some research, more research, and that's our big papa mammoth. So the one which can be used to do research and also do some knock down big trees potentially. So, all right. So that's what our station, to give you at least some idea of what's going on and how the place look where we work and live. So let's now talk about the steppe ecosystems, so the high productive steppe ecosystems. All right. So to start with, in the past, the world's biggest ecosystem, so in the Pleistocene, was mammoth steppe ecosystem. It was in Spain, in Canada, in China, in New Siberian islands, so in Arctic islands. So it was world's biggest steppe ecosystem, and the rest of the planet, most of the planet, was also occupied by other steppe ecosystems. And they were the most kind of strong and effective ecosystem on the planet. And it was interesting for us. We kind of knew a little bit about this ecosystem, and when my father started this Pleistocene Park project, but we needed to investigate more. If we kind of decided that we want to reconstruct those ecosystems, we need to know what we need to reconstruct. And there are some ways to find that out. So I will be talking about some of the research we did in the past to justify our work in the park and to kind of know in which direction we should develop the park. So without the same picture but without mammoths, here I will be showing, you see here in orange in the center, there are territories which are called Jedama. In this place there are sediments about 40 meters thick, which contain, there. So on Duvana Yar, they are very well seen. So basically it's loess which accumulated during the late Pleistocene and was preserved in the permafrost. It's in fact soils of the mammoth steppe. So when dust is blown and everything is deposited on the surface, slowly year by year, on average about 1 millimeter per year, these form these horizons. And since we have very thin active layers, so the layer which is thawing every summer, maybe up to a meter, I think in Pleistocene it was even less. So as soon as you put something 1 millimeter on top of the soil, bottom of the active layer will not thaw next year. So this was forming this layer by layer horizons of the lowest horizons of the mammoth steppe soils. And in this manner, so over the course of 30 to 40,000 years has formed the strata which is 20 to 60 meters thick. And there is some interesting things about this strata which we're going to talk about. That's another slide about it. The first thing I want to show is that these soils, well, this permafrost, is extremely carbon rich. You can see this zoom in picture where there is lots of fine roots, and the amounts of carbon in this territory, well, in this kind of soils, it's 2 to 4%, sometimes up to 15% by volume. And if you're accounting for this 20 to 40 to 60 meters thick strata, you can have actually more than a ton of organic carbon, very labile organic carbon, stored on every kind of square meter. So every square meter has up to 1 ton of carbon. Well, at least hundreds. So that's enormous carbon storage. So basically, to visualize, we usually say that if you take all above ground vegetation of the planet and put it on one side of the balance, and then took all these tiny fine roots which are in the permafrost of only like one state of Russia, you will see that these fine roots will be heavier. So they're heavier than all the kind of stems and of all the tropical forest, of all the boreal forest, of all the grasslands, alpine grasslands, shrublands through the entire planet. So it's kind of very big carbon reserve. It's one of the biggest carbon reserves on the planet and probably biggest terrestrial. So in addition, this carbon is very labile. So there is like organic, there is lots of nutrients in this permafrost. So you would be kind of amazed that this picture, which look very nice, is actually open cast gold mine. So a couple of years before this picture was taken, there was bulldozers who excavated all this permafrost, and they tried to reach the sediments beneath where some gold can be found. And a couple of years later, you can see that there is like enormously high production of all the grasses and plants, because soils are at least 10 times more fertile comparing with modern Arctic soils. All right. So another thing. So since they have lots of carbon in there, in case if permafrost is melting, greenhouse gases is starting to be produced. So microbes are currently sleeping frozen in the permafrost, but as soon as permafrost melts, they awaken and start eating. They are starving and they didn't eat for at least 20, 30, 40,000 years. And they start produce greenhouse gases. In case it's permafrost is dry, well, when it melts, thaws, it stays dry, it's in an aerobic condition, microbes produce CO2. But in case if there is wetlands, well, it's kind of, if it's saturated with water, if it's anoxic condition, they produce methane. These sediments, Yedema, is actually in our landscape is 50% ice. So ice is located in the form of ice wedges, so a polygonal net of ice wedges. And in case of permafrost degradation, these ice wedges melt and depressions appear. And in these depressions, water accumulate, and this forms little thermokarst ponds, which further grow and extend to lakes, these thermokarst lakes, and these thermokarst lakes migrate, so eating up Yedema, and underneath in the bottom of these lakes, there is always positive temperature, and the microbes are actively eating carbon and producing methane. So here is some shot of how if you disturb the bottom of the lake, you will see that much bubbles coming up. It's like opening a bottle of Coca-Cola. If you walk on the bottom of the lake, it's just like boils around you. And in the winter, there is when ice on the lake freeze, all this methane, you see those white spots are trapped underneath the ice. And let me go to some video. And in the winter, you can make some like fun entertainment. Maybe I think some of you saw that's kind of very popular among different media to show videos like that. Yeah, so there was a bubble of methane which had maybe, I don't know, 200 to 100 liters of methane, which as soon as you flame it, burn. So it's actually, yeah, that's an image of my father who was doing the same thing in front of the camera. Very nice shot. All right, so yeah, but apart from carbon, so we know that permafrost is the biggest carbon reservoir, and it has lots of kind of potential to be thawing in the future, since the climate is warming right now. It's kind of danger. But what else this permafrost can tell us? There is actually lots of remains of the mammoth steppe ecosystem animals can be found in permafrost. So these are kind of like some of the collection which we took to show. All right. So, and if you walk along the place where the permafrost is eroded, you often find bones of like these animals. And for many people, actually, in the local people here in the region, it's kind of a profitable business. They go and look for the places where lakes and rivers erode permafrost, and they search for mammoth tusks or woolly rhinoceros horns, and they make quite a good money out of it. Well, we don't do that business, but we also were interested in collecting bones of these animals for the reasons to find out actually what's the density of animals. Because if you want to create our Pleistocene Park, we need to know how it was in the past. We kind of there is very little information how to restore ecosystems, and doing that blindly is kind of like just a waste of time. We need to at least have a vision of how it was in the past and try to more or less copy and see the final goal. So what we did, I think this research was done, I think in 2007, it was late autumn, so it's also the 1 year exposure, which we often kind of use as our research site. And there was a big storm, and then water level dropped, and you see that normally a river erodes the shore, and all this silt and loess, also all fine particles are eroded by the river, and all the heavy particles, and which is basically only bones. So the only kind of, there was no wood in the Pleistocene in this place, so any big piece of kind of basically any of organic material is a bone. So when the river rolls, all the bones basically project here on the beach, and if you walk, you can find them in abundance. I think we walked for around 3 kilometers, and we found more than 1,000 bones. Just like other. And the thing, let me see what was, yeah, so that's bones we found walking for 3 kilometers along this beach, so basically 10 meter wide. And we kind of located all the bones in the collection according to their like species and where they are kind of found. So the legs of horse are placed in the kind of, you see, we tried to kind of make those little skeletons out of the bones we found. So the first thing we noted that when we walked, the bones of reindeers, horses, and bison we all found on the shore randomly. So just like there was no kind of system. Like you walk, you find it here and there, but all the mammoths we actually found in accumulations. So you walk for 100 meters without seeing even a single mammoth bone. And then you encounter one and you look around and you find another 3, 4, 5, 6, 7 different bones of mammoths. And moreover, all these bones looked of the same preservation quality, same color, and the size of the bones indicated they could belong to one animal. Then walk another 50 meters without seeing any other animal bones of mammoth, and then encounter another accumulation, and also like 3, 5. And as we walked, we found 29 here. It's 29 different accumulations of mammoths, of mammoth bones. And from that, and we did not find even a single, like, not a single bone was found, like, kind of separately. So all of them were in accumulation. So this made us draw us to a conclusion that all these kind of accumulations actually remains of a single animals, single mammoth. So we understood that we found remains of 29 mammoths laying on the shore. Okay, then we knew that we walked for almost 3 kilometers. The area of the shore was, the width of the shore was 10 meters. And we basically have increased that by 50% to account for the kind of this border conditions, and estimated that. So we've searched certain area, and we found 29 animals there, and this kind of gave us the density of skeletons in that location per square kilometer. So now, right now, on every square kilometer of this Yedema in the region around Pleistocene Park, remain around 600 skeletons of mammoths. Okay, then we knew that it's 600 skeletons. Okay, and we knew that this strata, which is located on the 1 year, started accumulated around 45,000 years ago and finished around 15,000 years ago. So it was accumulating for 30,000 years. And if you divide 600 skeletons by 30,000 years, you will see that every year to the permafrost was supplied 0.2 mammoths per year, well, per square kilometer per year. And then, you can find out what's the age of the tree by counting the rings. And also there was some studies counting rings on mammoth tusks. And it revealed that mammoths in Pleistocene lived there on average up to 50 years. So it means that if one animal dies, there is 50 more roaming around alive. So basically you multiply this kind of number of skeletons by 50 and you receive the density of mammoths on this place in late Pleistocene on average, like over 30,000 years. And we received the number that on every square kilometer there was 1 mammoth. Well, that's kind of really a lot. So only mammoths were like a number of millions already in the Arctic. So for why we kind of did that research, tell that just maybe 20 years ago, it was broadly assumed by all scientists that Arctic, Siberian Arctic, was a polar desert in Pleistocene. So there was no carbon there, there was no animals there, and people who outside of this kind of research kind of never accounted for their, like, for example, in the global carbon budgets, they never accounted for this ecosystem. And here we show that no, it's actually one of the biggest carbon reservoirs, and there were millions and millions of animals. So it wasn't a polar desert. But okay, but real mammoths are dominant species. So maybe there was only mammoths and very few of other animals. And for that, we did this statistical analysis of trying to find out how well the bones preserved in permafrost depending on their size. I will not go into big details here, but we did a very good linear correlation between the size of the bone and the probability of it to preserve. And then doing bridges between different animals and sizes of the bones, we estimated that on average, on every square kilometers in late Pleistocene in the high Arctic lived 1 mammoth, 5 bison, 8 horses, and 15 reindeers. So it's no kind of enormous amounts, number of animals. It's about 10 ton biomass per square kilometer. So for your kind of visualization, I would say that if you would climb up the hill, so near our station we have the hill. This is about 300 meters tall. If you climb up in the sunny day, and if you would look around, you would on average see around 2,000 to 3,000 big animals. Right now, I've been on this hill, I don't know, tens, maybe probably hundreds times, and over this entire period, I haven't seen even a single animal. So that's kind of the dramatic change. So come any day in late places into that place and see thousands. Come there now and see nothing. All right. So just from ecological point of view, if you have 10-ton biomass of animals, you are actually very limited with what kind of ecosystem and what kind of situation could there be. First of all, that's what this ecosystem was a steppe, because no other vegetation can maintain that number of animals. So it should be the most productive grasses and herbs. Only these plants are able to maintain this enormously kind of high animal density. Then there could not possibly be really any shrubs or trees, because such animal density will trample down everything. So no vegetation apart from grasses can actually sustain such grazing. So this shot is done in the park many years ago. Right now we're actually renovating this fence at the moment. So you see the difference. That's bare land. It's kind of impossible for any tree to establish in that place. Then we actually kind of know how much precipitation there was in the past. And we found out that in order to supply enough forage for animals, basically every single drop of precipitation must have been used for photosynthesis. So all the soils were dry, and so water was limited resource, and plants were kind of drying out the soil, and there was no lakes at all in that place. There was no wetlands, unlike there is now. And also, since it's kind of high Arctic, and there was also lots of predators in this ecosystem, there was no problem with overgrazing. It can be often happening in the humans' activity and pasturing, when they kind of do not pasture animals well, and there is overgrazing and desertification take place in different places of the world. So that wasn't the problem in this ecosystem. And also the thing about this ecosystem and why we actually kind of care about it now, and why it's kind of taking so much attention, is that this ecosystem, being so big, so productive, so aggressive, was also not only kind of sustaining in the Arctic and in the kind of glacial climate, but it was also promoting the glacial climate. So there is kind of few things how it was happening. So first of all, steppes are much lighter compared with forests and shrubs. So you see in this picture there is on the background there is a forest, and there is shrubs close, and then there is in the front there is grasses. You see they are lighter, so they reflect higher portion of sun energy back to space without transforming that to increase temperature. So this effect is actually especially pronounced in the right now. So in the Arctic there is so much sun now. Basically every day is extremely sunny, and you can kind of barely walk without sunglasses on, and that would hurt your eyes by the end of the day. So we have lots of sun already kind of in the Arctic, but everything is still covered with snow. And you see that there is a forest on the background which is black, and so those dark stems are getting heated by the sun. So already within the next few couple of weeks, most of the snow around those trees will melt because the stems from kind of heat from the sun, and they melt the snow around them. But you see the patches right now are still covered with snow, and they stay white. So for maybe one extra month a year, the difference in albedo is like, let's say, from almost 100 to maybe, I don't know, 10-20%. So it's a kind of enormous change in albedo in the spring. So if you have steppes, you reflect much more energy back to space. Then, which is kind of the most actively discussed now, is that animals allow to keep permafrost colder. So if you don't have any animals, you have snow formed in the beginning of the year, and in the beginning of the autumn, I mean, and no matter how cold it gets in the winter, like in the Arctic, so it gets to minus 40, minus 45, minus 55, but regardless of that, the snow does not allow soil to freeze because it acts as a blanket. So if you have minus 40 outside, underneath the half meter of snow, it will not be colder than minus 10. And animals are actually kind of solving that issue. So since they have lots of animals and they need to eat year round, they go and they trample down the snow and they search for food, and they visit every piece of land a couple times over the year, trying to find enough forage for them. And they trample down the snow, and instead of half meter of the very soft, very well insulating snow, you have maybe 5 to 10 centimeters very thick, very dense snow cover, which lose most of its heat insulating abilities. And soils do freeze way colder. So there is some preliminary data we had with some sensors once located in the grasslands where there was no herbivores, to the right, slide to the right, versus the place where the animals actually actively grazed that winter. And you can see that temperature drop in the soil down at like 25 centimeter depth, down to 20 degrees, while in the place where there was snow cover, it was intact, kind of substantially higher temperatures. So this kind of it's of course this kind of method do have some limitations. So basically, the best animals can do is to have permafrost temperature equal to the average annual air temperature. So unfortunately, animals will not be able to save the permafrost in case if average annual air temperature will be over more than 0 degrees. And so the effect which Pleistocene Park can have on kind of keeping permafrost frozen is kind of also dependent on how strong will be the global warming in the future, how much greenhouse gases we will produce. So it's kind of, it's for people to understand, it's not kind of like ultimate solution. That's kind of a way to mitigate, way to prevent, way to postpone. But it's kind of like important for us. It's kind of, it will buy us some time. Because in case if permafrost will melt, it will be the strongest natural source of greenhouse gases on the planet. On the kind of the mildest and very, how to say, conservative estimates, it will bring another United States on the planet in terms of how much greenhouse gases will be produced, additionally emitted. Some people, some scientists say that it will be even like equal to the amounts of greenhouse gases going from permafrost will be equal to the amount of greenhouse gases going from like anthropogenic emissions. I'm not that kind of, I'm kind of more rooted to the more conservative, so I would say 20%. But it's kind of, it's a lot. And we are already going on the worst case scenarios of global warming. And in case permafrost will start melt everywhere, and it's already halfway there, we will face big troubles. And we don't want to face big troubles. All right, so what's next? Yeah. there are also some science. Steppes they don't have much above ground biomass compared with, for example, forest, but they allow to build up lots of below ground biomass. So how it's done? So basically, how much carbon you have in the soil depends on, like, since I was a math major, I was always writing equations. So it's kind of how much you have inside depends on how much is your input, how much is your output. So your input is mostly going with grass roots. So you have grasses, herbs. Every year they need to pump water, and they build up the root system. So it's a organic carbon which stays in the soil. So all the output is basically decomposition. So old roots die, decay, and convert to greenhouse gases and emit it back to space, to the atmosphere. So let's discuss about the input. So basically, input is basically some fraction of the photosynthesis, and photosynthesis is photochemical reaction. It's not in that big dependence on temperature or the climate. So there are some plants which can actually photosynthesize at +30, and some which can do it at +1. And so it's like photochemical reaction. It's mostly dependent, like productivity, potential, like photosynthesis productivity is dependent on duration of vegetative cycle. So, for example, if in kind of temperate zone, it's, let's say, 5 months, then in the Arctic maybe it's kind of 3 months or 2 months. So productivity would be, let's say, twice lower. So, and the input of carbon into the soil will be twice lower than comparing with temperate forest. So smaller, but still quite big. However, the decomposition rate in temperate climate and in kind of Arctic climate is extremely different. So we do have permafrost underneath. We have most of the active layer frozen all year round. And even in the summer, some horizons of soil are thawed maybe just for a few weeks a year, and temperature never rise more than like at +1 degree there. So if you would put just even a little carbon roots there, like if little bit of roots will grow there. For instance, if you have dry soils and plants are in need of water, they will grow deep. Maybe it's like very unpleasant there, it's very cold, but roots will go there, and once they get there, they will decompose orders slower comparing with how fast they would decompose in tropical or temperate climate. So this difference between, so there is some scientific graphs we showed, so very little carbon in the temperate climate, but in case you have permafrost, you can build up lots of carbon. So right now, it's kind of example of how permafrost and how Yedema actually managed to accumulate that much carbon. So in the Pleistocene, this ecosystem was doing the same. It was accumulating and absorbing carbon from the atmosphere, and it's created huge carbon storages. Most of it actually already were emitted late when the transition of the Pleistocene Holocene appeared, and which and even there are things, carbon which is left there now in the remains of permafrost is still enough to make our life quite miserable in the next couple hundred years. All right. So, and also, if you have very high productivity of vegetation, and if they suck all the water out, you don't have any methane produced, and that's kind of very critical because methane is a way stronger greenhouse gas. So, if you do have some carbon which will be released, you really want that to be released in the form of CO2 rather than in the form of methane. So these are the kind of main 4 features of this which allow it to kind of shape the climate. So I will say again, so it's albedo, it's preservation of permafrost, it's absorption of carbon. Absorption of carbon is a slow process. I kind of also should understand. My rough estimate would be that if we would create Pleistocene Park over entire Arctic, it would take around 6,000 years to suck all the carbon back to soil, which humans have emitted in the last 3 centuries. So it's not also kind of like the ultimate quick solution, but it's kind of at least the walk in the right direction. And also, so there would be much less methane produced in this ecosystem. So these four features about this ecosystems which are very critical. And also, so when we estimate the density of animals in the 1 year, so in the region around Pleistocene Park, we know that steppe ecosystems were worldwide. And we know that our place was one of the coldest and had one of the fewest precipitation. So the productivity in our place, in the region of Pleistocene Park, was one of the lowest on the planet. And still we had 10-ton biomass. So in the place where there was warm and there was more precipitation, productivity of steppe ecosystems was even more, was even bigger. So 20-30 tons per square kilometer. There are some places on the planet right now where there is productivity, 30-ton biomass per square kilometer. So it's not something like impossible, but that's kind of extremely, really a lot. And we know that these steppes were everywhere. And from that we estimated what was planet biomass of steppes and of big herbivores. And we found out that, so our modern civilization, so we burn all the kind of non-refundable resources at the extreme rate, so that we polluted the entire planet. And we do that to keep our, 7 billion people and several billion cows, pigs, chickens, which maintain our lifestyle. And if you take if you combine all that, so the biomass of our civilization, plus all the wild animals which are left, so the biomass of big herbivores on the planet, including humans, and compare that with biomass of animals in the Pleistocene, you will find out that natural ecosystems solely on refundable resources manage to have at least 30% higher population, higher kind of biomass compared with what we managed to get now. So this is not only about that we are wasting resources, but also how ineffectively we do that. So all the agricultural, so this all artificial ecosystems we build are so much less effective compared with wild ecosystems. So if you have just one cow, one grain, you get and you collect one harvest a year, you get way less effective kind of ecosystem compared when you have several tens of herbivores and multiple different predators around that place. So our civilization do have to learn a lot on how to manage our planet correctly. So, and we need to learn that, and we need to do that in order for our civilization to survive. All right, back to the problem of so when we are creating mammoth steppe, we are not creating mammoth steppe directly, we are creating high productive steppe ecosystem, because we don't have mammoths. I don't know when they will come, if they will come. Many animals already evolved, some other animals are extinct, so we cannot replicate the mammoth steppe ecosystem, but we can replicate the idea of high productive steppes. And for us, it was quite important to understand. If you want to replicate mammoth steppe, somehow we need to find out if it can be replicated. Because at some point, this ecosystem went extinct. And it went extinct for some reason. And what was the reason? And by many scientists, it was assumed, it's still assumed that, Pleistocene climate was dry and cold, and it was good for animals, and then it turned to Holocene climate, which was moist, wet and warm, and animals did not like that climate and all died out. Well, that's let's rephrase it. So there was, let's say, in the climatic field, in every place the climate shifted so bad that animals in every place of the areal of the mammoth steppe disappeared. So, and we started investigating. So, okay, we know that many animals, which lived in this ecosystem, persisted till Holocene times. So some horses lived in 9,000 years. Mammoths on the mainland lived until also, I think on Timor lived until 9,000 years. Some we found 11,000 years ago. So many animals we found in the modern climate. So Holocene climate was stable. So many animals persisted for tens of thousands of years, well, for thousands of years, I mean, in this climate, and means this climate is suitable for them. And we kind of searched in the literature, and we found that animals in this ecosystem actually kind of lived in this, let's say, climatic envelope. So it's like a precipitation, so two-dimensional space. It's not like a longitude, latitude, but it's kind of precipitation versus how much like sun energy is hitting the surface. And so you see this like red kind of field area. It's a place where we estimated the animals live. And all of these territories, like, and those black dots, actually meteorological stations around the Arctic. So most of the current Arctic is actually having suitable climate. And also, mammoths, this ecosystem was in Spain and the Arctic islands. You cannot expect this kind of ecosystem to be kind of very kind of narrow and very demanding on climate. Because Spain and Arctic and New Siberian islands are two absolutely different places. From both of like kind of how much temperature, how much precipitation they have. So this ecosystem was very independent on climate. And if it wasn't the climate, well, it could resist in very high variety of climates. But if it wasn't the climates which killed it, then what was it? And there is like actually perfect correlation between the collapse of all animals, or the population of all the animals, and the first arrival of humans to that place. So basically, Arctic was free of humans at that time, and then in Pleistocene. And then when Holocene appeared, first of all, actually all animals increased their numbers. As soon as you get warmer climate with more precipitation, you can grow more grass, and you can have more animals. So there is like I don't know if you see my mouse. So with every single species, there was increase in numbers as soon as climate warmed. But shortly after that, humans appeared, and there was a dramatic collapse of all animals. So as we know that any kind of humans started the expansion somewhere from Eastern Europe and moved to the Siberia, then to the Arctic, then through Bering Strait to United States. As the further they went, the deadlier were the kind of consequences. So this is like a nice picture slide from some old book showing the kind of results of extinction of animals in the kind of Pleistocene, well, in Europe. And in Siberia and then in America, and especially in South America, effect was even kind of greater. So the theory is of overkill. So people came and killed everybody. Let's say many people say, well, prehistoric humans did not have tools or need to kill or possibility to kill every animal, so the situation doesn't work. Well, probably they could not kill every single species, because as soon as you get rid of 90%, it's very hard to hunt the rest. But you don't need to, in order to get some animals extinct, you don't need to kill all of them. This ecosystem was a combination of animals and plants. So grasses can grow in that place only with help of animals. So animals have to eat them, digest them, and keep the very high cycle of nutrients. They have to fight with grass enemies, so they have to trample moss, they have to trample forest. And in case, imagine there came humans and decreased population of animals 10 times. And already in a few years after that, all the grasses will grow and no one will eat them, and they will stay as litter. So we have very slow decomposition in the Arctic. So all the grasses will stay intact. They will keep all the nutrients in, and no one will fight with new forest, with shrubs which will grow. And already within next decades, centuries, this ecosystem, these grasslands will be gone. And imagine you're a mammoth or a woolly rhinoceros, and you're not, and you need to have lots of energy for your maintenance. So mammoths and woolly rhinoceros did demand extremely high productive pastures. So for such a huge body, you have to eat day and night, and only the best food. And at some point, they figured out that there was no best food left. there was some grasses, but they was eating with grasses, with shrubs and everything, and they could not maintain enough kind of energy. And like I, how to say, speculate that last mammoths on the continent died not because of the spear, but because of starvation. So you don't need to destroy, kill all mammoths. You need to kill the ecosystem they lived in. So when this, as soon as you kill the ecosystem, those animals have no place to stay. So some horses, some bison can adapt. They can hide in the forest. They are smaller. They kind of they have less demands on good forage. But the bigger you are, the more complicated it is for you. So back then, humans kind of the nice sentence which I actually really liked from the Atlantic magazine, which came was published about our park. It was saying that so destroying of this ecosystem was the I think original ecological human sin. I really like that phrase. So that's kind of, and I really think that it was. So humans, just 15,000 years ago, humans already kind of changed the outlook of the planet more than all kind of the modern civilization did. So what we have now, it's kind of all the modern ecosystems. So it's tundra, other taigas, or polar desert. So basically there is nothing to eat in this ecosystem right now in the Arctic. So I was driving through Arctic a lot in my life. And I basically could never encounter even a single wild herbivore. Or you have to drive hundreds and hundreds of kilometers and hope to see some moose. That should be kind of luck. So what we have now is kind of, there is no humans really living in that place, really few. And these ecosystems give absolutely no profit to people. But we speculate that the reverse shift is possible. So humans managed to destroy this ecosystem by reducing the number of animals. But we now try to kind of do the opposite. We try to bring animals in and allow them to transform the landscape back. So if you start trampling, for example, if you would knock down these trees and trample the moss, grasses will start growing. If you add fertilizers, like if animals will add dung to the soil, there will be even more grasses growing. So, and the more animals trample, the better grass grow. So, kind of the more they harvest and the higher the kind of the faster the rate of nutrient cycling. So, yeah. So the slide. So this is the kind of similar locations. So in case actually when this permafrost underneath the modern forest will melt, and there is big chance that will start happening in the next 10, 20, 30 years. All the modern ecosystems will be destroyed, and all the landscape will actually very soon look like the slide to the bottom. So the grasses and herbs. And if you would have animals coming there, they would eat all these plants, trample the snow, and they will actually stop permafrost from soil degradation. So this is the tundra, so basically nothing is growing, but around the camps, if you have fertilizers, you have actually very high production of grass, even in tundra. And this picture we took on Wrangel Island, so it's basically nothing is growing there. But if you have fertilizers, and we know, for example, mammoths lived in this island until 3,500 years ago. Basically, the mammoths were still roaming on that place. And if you add fertilizers even to this like extremely cold environment, you do have grasses grow very well and produce enough forage, even for mammoth. So, yeah, so that's exactly what we try to do with the Pleistocene Park. So we got the land, and the problem of creation of this ecosystem is that in many places of the planet, try to create a wild ecosystem will have, resistance from many humans, because they would need that land. They don't want to be neighbors to the wild ecosystem, and humans did have a strong, kind of complicated relationship between with wild ecosystems in the past, and they were kind of always considered themselves as enemies. And now we say that if we want to, in the future, to live and sustainably develop our civilization, we need to learn to be friends with wild ecosystems and how to mutually coexist. So, and high Arctic right now is a good place to try our experiment, because it's abandoned land. No one really using that much, and we are able to kind of create kind of large-scale ecological projects right there. So, so what we do? So yeah, we got the place which no one need. We started building the fence. So there is some. Now I will again go. I will be done with science, and I will be just showing some of the activities we were doing. So we were building the fence. In order to build the fence, you have to actually steam and boil the permafrost. And actually, right now, like I was doing that yesterday, and right now my workers are continue doing that. So we are renovating some part of the fence, and we use the steam drilling machine. So you boil the water to produce steam, and with that steam, we kind of melt the hole in the ground and insert the pole there. And next day it's frozen, back frozen, and you have intact poles. Yeah, so you see that we collected nets. So we currently have around 20 kilometers of fence in the park. And then after you build the fence, you start bringing animals. So the first animals, it's the local dwellers. So there is, first one I will be showing pictures is how we catch moose. So there is a mountain river about 160 kilometers up the Koloma River from the station. And in the summer, there is a mother moose with babies. They kind of tend to hide in the islands. This mountain river has lots of like rocky islands. And animals tend to hide there from mosquitoes because mosquitoes are really bad at that time of the year. And if you scare the animals, and they will run into the water, and you can just grab the baby moose and transport it to the park. So it's kind of like the way not to tranquilize or kind of animals. So we didn't do that too frequently, but few expeditions we did, and we brought some. You see, there is some baby moose we caught, and they kept in the nursery for the first couple months. So we feed them with milk and with kind of concentrated food. And all of them actually did very well, so none of them ever died in the nurseries. And when they grow a bit bigger, we kind of release them into the park. And actually, already by the autumn, it's actually the last time animals actually approach. Very soon they kind of and walk freely in the big fenced area. So yeah, sometimes yeah. Some of them are friendly. Mostly they don't allow people to come. So that's an old picture. We had this moose for years living in the park. Then horses. So Yakutian horses are actually another semi-local animals which we introduce into the parks. So for them you drive for another 500 to 800 kilometers away from our park, and once we did the expedition with our Papa Mamas. You see that tank on the background, which we use the tow sledge, and sometimes by trucks. So you round the horses. So those horses are kept by Yakutians as a domestic animal. They're kept for meat, so it's a meat breed, and we were buying them and releasing them to the park. Well, we did several expeditions over the time, so we do have some population of these animals in the park. They do well. They're not a perfect animal for the park right now because we still kind of promoting the vegetation in the park, so the landscape, and they are pure kind of pasture, so they eat only grass. They don't eat shrubs, but they're doing relatively well in the park. So here are some other shots. Then reindeers. We normally bring reindeers in the autumn. Well, we did a couple expeditions to bring them in the autumn. We buy them from local reindeer herders. So also there are some shots of how we do that. So you catch it and you tie it, you put it to the boat, drive it to the park, and then release it. So you see me carrying the reindeers. They don't really like it, but so there is one reindeer in the park. We actually did, I think 3 days ago, we did expedition. The first time I was bringing the animals in the winter, so we took 3 snowmobiles and drove maybe 50, 60 kilometers away from the station, across the Koloma River, and maybe 15 kilometers up to the Tundra, where it's like absolutely no vegetation out of the snow. It's all flat, and there were some herds of domestic reindeers which we rounded up, and we caught 11 reindeers. 10 of them were pregnant. Well, they're still pregnant, so we really hope to get, instead of 11 animals, I hope to have 21 by the time I come back to Chersky. All right, then kind of, so those are local animals which are kind of relatively easy to get, but sometimes you have to make more kind of extreme trips. So this is a trip in 2010 we did to Wrangel Island. So we had this little gray boat which we own on the station, and which we took to that 1,000-kilometer ride through the Arctic Ocean. And there was some, so I will show some slides of the way. So the nice sunset, that's how we landed on ice. So it's Arctic Ocean, there is lots of floating ice, and there was lots of floating ice on the way. We actually had to move almost all the way to Alaska to find the path through ice to get to the island. And we saw some like wildlife on the way, so it's polar bear floating. It was, I think, around 100 kilometers from any land, so it was living on big ice sheets. There are some walruses. It's all the pictures taken on the way there. So then we came to the Wrangel Island, and we had to catch muskox, and it took us 10 days to find those herds. And the person, so the head of this national reserve, was tranquilizing them, the babies, and then for the few hours I had to pet them until they wake up. They're very warm, and the fur is extremely nice. So yeah, that's my picture with the baby. It's still sleeping, but you have to hold it because sometimes they can like awaken quickly and escape. Yeah, so that's, we rounded up, like caught several, and then we that's another cute one. Then we took them to the cages and transported down our little deck and released them in the deck. So they were, and on the way back we actually experienced extremely strong storm. So we were, for 2 days we were in the open Arctic Ocean and experiencing all these waves where you could barely stand. All the crew was seasick. Same with poor baby muskox, we were also sick, but their quarters were the most comfortable. They were like at the very bottom, so they were shaking not as bad as I did. But all of them, so we went fine. So we finally kind of reached the mainland shore and went along the mainland shore. Some extremely nice sites along the Arctic coast in Russia. So those like huge cliffs, they're about 30-50 meters tall cliffs, extremely nice. And then we got all the muskox to the park, and here they are. So now they are adult and roaming around. Well, only bad thing that we caught 6, and all 6 of them appeared to be males. So we are now actually in big demand to find ladies for them. And it's kind of very complicated since, like, I don't really want to do that trip to Wrangel Island again. It's kind of like, let's say I have too many kids to risk my life once again. But it's kind of like our goal to find more in the future. Maybe next year I will kind of work very intensively on that. Then there was probably my personal most extreme trip I ever did. That's how I bought a truck and I drove through entire Russia to Altai and picked up some elks and got the elks into the truck, and then I started driving through Russia with elks in the truck all by myself. That was in 2011, so I came, it was already Lake Baikal, and then it's like border of Mongolia. Then I started going north, and well, I didn't really I tried to catch up after the winter, but I was really late, and all the winter roads started to kind of melt. Oh, that's kind of nice road. It's a federal road between 2 big Russian cities. So when people say that roads in Russia are bad, they don't lie you. So I tell you. And yeah, there is hundreds of meters down to fall, and it's kind of like very hard if there is 2 big trucks going on that road and they need to kind of go past each other. It's like a big hassle. And then last 100 kilometers, so last 1,000 miles, there was like even that road stopped, so and you had to go use just like the path in the kind of landscape. So you see how perfect the road was. And some horses I saw on the way. some of them tried to race me. So people, Yakutians do keep them as a kind of meat breed, as I said. So there is quite a lot of them through Yakutia. And I was going, it was like lots of ice was melting, so all the rivers which I used as roads were melting. It was a big danger actually to go, and my truck was last that year which made it to our town, because there was 5 trucks going after me and all of them drowned. Well, fortunately none of the people died, but it was a big risk. And finally, after 25 days of travel, well, kind of my 25 days of travel, elks spent 2 weeks in the truck. They got out. Well, obviously that wasn't the most successful animal to bring, because they spent the year in the park, and then next summer they all of them just jumped out through the fence, because our fence was kind of too short, well, not tall enough, and escaped. It was a kind of very, very sad for us. Well, so that's why right now we are building the fence, which is at least 1 meter taller compared to which we had back in the time. So yeah, that's an old slide from the kind of presentation. So right now our plan is to bring bison and yaks. So the reason for us, we started the Kickstarter campaign last month, is that because we want to extend park with new animals. So we want to bring bison and we want to bring yaks. And we already kind of quite, well, it went not that bad, so we already reached our goal, which is, well, goal was quite, we try to keep it low, so our demands, and we would need way more to do lots of things more in order for our Pleistocene Park to develop in the future. So that's why we decided kind of to have that campaign and to collect money. And the kind of motivation that so far, like everything I showed you, we did ourselves. So we run this Arctic research station. We do have multiple grants. We gather some money. We maintain the station out of that, and all the profits we made. So for the last 20 years, we were investing into building these fences, trying to bring animals. And since kind of we are limited with resources, we kind of, if I would have enough money, I would fly those animals in. But since it's kind of not really an option, we had to kind of go into all those extreme trips. And kind of for the purpose of a scientific experiment, our kind of efforts and our resources are enough. But if we want to establish an ecosystem which would expand and in the future would be able to mitigate climate, we do need other people to participate in our project. So that's kind of like a big demand. And since the climate is warming and permafrost is about to start melting like very soon, within the next decade, probably, we need to kind of take like urgent actions. And that's why kind of we now trying to reach as many people as we can, and we're trying to show and tell them what we do, and tell them why it's important and kind of why we need their help. So I think I'm done. Thank you.
Nikita, that was an incredible presentation. Thank you so much for going over that. That's fantastic.
Any questions?
Oh, we've got a whole bunch of questions. But before we go into questions, just letting people know, one of the reasons we want to put that on is, though they were successful with the Kickstarter, this work is not going to be done for a long time. They're going to need to go out and quest and find bison and yaks. This is one of the greatest endeavors of our time, and this is a great opportunity right now if you want to help Nikita. Let me pull up the Kickstarter here so folks can see it. I'll change the presenter real quick. All right, give me 1 sec. There. So right now they're at 112,253. That's great that they met their goal, but I think we can help them even more. And we want to give you guys something that if you decide to donate right now on this Kickstarter, if you donate more than 150, we will give you access to a year-long membership of Sustainable Design Masterclass. That's worth $250. You know, normally people pay more for it. If you donate 500, you get that and a consultation with Neil Spackman on any regenerative agriculture project. And here's the big thing: the biggest donator to this is going to get. I'm going to get all that. Plus, I'm going to send you like 2 variety packs of organic mead from Frank Golbeck. So you're going to get that. Doesn't matter where you are in the world. We're going to ship that to you. So we'd love to have you help. This is a great opportunity. And, yeah, we just love any way that we can help Nikita. Hopefully we can do that because, man, I'm in the tech bubble right now. People throw billions of dollars towards tech projects. We're in an existential crisis, and Nikita and Pleistocene Park, they need $1 billion for this. You guys need all the funding in the world, and hopefully this is the start that gets you the attention you need to bring in massive international funding. So hope we can help in any way we can, and hopefully this is the start of something bigger. So questions. So question time. Like I was stoked to see Richard Perkins with us. He's a really great, profitable farmer in Sweden. So he had some questions. First of all, he said, you guys are taking epoch to another level, and he's definitely true. Richard, why don't you type in your question one more time? I think I typed it in. But, all right, Richard says, I'm curious if eventually you could imagine bringing in predator species.
Nikita, can you imagine bringing in?
We definitely need. Yeah, first of all, I certainly do think that we need predators. For example, there is this guy, Alan Savory, they are doing this research on how to pasture animals correctly so they work for farmers. And the difference in our we really support what they do, but the difference in our vision that we want to make wild ecosystems, and we are showing that proper pasturing and avoiding desertification and avoiding over trampling of soil should be done not by manipulated by people that they transport animals from one place to another, but by animals, by predators. The main goal of predators is to separate animals from one place to another, because otherwise animals will be herbivores will accumulate in the place where the best grass, over trample it, and the rest they will not eat. And predators allow to spread and force animals to separate and not keep in a high density in one place. And also, the predators are the best pasturers. Humans have actually to learn a lot from wolves and tigers how to manipulate animals. So yes, we do need predators in the future. So right now we need to increase the number of herbivores in the park. So that's the first goal. And then once we will start not just blindly throwing predators in, but we'll slowly introduce animals. We cannot if we will now bring professional tiger from taiga, this super killer to the park, we might have a drop in population. But we need since our herbivores never seen a predator, we need to find a predator that have never seen a herbivores. So and slowly allow them to learn how to interact with each other. So yeah, that's our future goals. We do need to do that.
Awesome. So Richard has a follow-up question. He says, thank you so much, Nikita, and to your father. Your work is mind-blowing. He says, what sort of animal numbers do you imagine before you can bring on predators?
Let's say, I think about starting 500 herbivores, maybe to 1,000. Well, that would be my blind estimate.
Awesome. So Jackie Miller asks, are you considering bringing any cattle, which might be easier to help jumpstart the system while you build up other breeds?
So right now we are bringing yaks and bison. There is some options. So there is Yakutian cow, which is probably actually the problem is that they are not that abundant anymore. So Yakutians do have this own breed, which they can survive in the Arctic, but even they kind of like they need treatment. My dad, so we have, apart from the park, we a few years ago, actually kind of one of the reasons was that we wanted to have like productive steppe ecosystem quickly and cheap. We started another park which is called Wildfield, which is located 250 kilometers south of Moscow. And so we wanted just to show what's possible, like how many animals can be located in one place. So place which is easy for people to reach, because Pleistocene Park is very remote. It's very expensive to get there. But this place is on the road, not far from Moscow, and there is a nice steppe there already. And we just need to kind of populate with some animals and give them a few years to increase numbers. And we were bringing in some animals, and my dad, we tried cheap options, and one of the cheap options was Kalmykian cow, and it did incredibly well. I think we already have like almost doubled in a few years, and they resist. Well, kind of Tula region is not the most expensive place, but well, okay, not the most expensive, not the coldest place, but they did very well. And my dad was actually saying like, "Oh, Nikita, do you consider maybe bringing Kalmykian cows to the Pleistocene Park?" I don't know. I think that still we would need some, like all the cows would still need the treatment from our side, while bison do not. So I think I would actually maybe idea is to buy, I don't know, 100, 200 bison from, or 50 bison from the United States, and maybe rent a big cargo plane. Well, in case we'll get like enough funding in the future. So the goal is to bring a kind of big portion, like big group of bison, ideally wood bison, to the Pleistocene Park from the United States. I think, or Canada, that would be kind of the better option, because cows are, I'm afraid that I will bring like 100 animals, and by next year most of them will die. So it's a big risk.
Yeah. So the follow-up question from Anard says, can these animals survive during the winter at this latitude? And he's coming from France.
Yes. Cows on themselves, not sure, but yaks and bison, yes. We do have one bison now living in the park, so it's a European bison. It's like the problem of like first year adaptation, for which we will prepare. So now we are bringing animals, and we will build. So two things we will make sure for them to survive the winter. So we will make the shelter in which animals would be able to hide in the autumn. So, and also we'll provide lots of forage for them to make sure they like eating enough in the first year. Because itself, winters are not that, and temperatures not that, not a problem. Problem can be that if you bring animal, for example, from Moscow, in Moscow, winter come, I don't know, in December, in January, and animals change summer fur to winter fur very late. And if they're brought to Chersky and they start to change fur in November when it's already minus 30, it's kind of like maybe very bad for them. But as soon as they change fur and as soon as they adapt to changing fur in the proper time, they're doing fine. So we do have a bison which was born in Moscow and lived in Moscow for several years. And then it came to the park, and now it's, this year it was minus 55 for a couple of days, and it was with strong wind. Well, not strong, but with wind. So it's like incredibly bad, like kind of severe conditions, and it did perfectly fine.
Awesome. Okay, so this is a question about your father's work from Kathleen. She says, Zimov, your father's Wildfield Manifesto is a terrific read, presenting a story of how mankind and the wild world became enemies. I read here that animals can survive on these lands without additional feed or control. I understand average temperatures in Siberia in January is negative 25 degrees centigrade. How will grass eaters survive the winter?
No, it's not minus 25. It's minus 33. They do well. Like, as I said, low temperatures is not a problem. Forage availability. That's like the main. None of my none of it, well, kind of with bison, so there was some troubles with adaptation, but animals are not dying because of the cold. They're dying because of like not enough forage. So they survive well, so that's not a problem. You cannot imagine like actually how much animals can adapt. There is Novosibirsk, so it's like so-called capital of Siberia. They have a very good zoo, and Novosibirsk it's often dropped to minus 40, minus 45 in the winter. And in that zoo, they have a population of African lions living there for I think almost 50 years outside. So it's an actual population of lions which breed, which kind of like they sell them to different places already, and for 50 years those animals successfully live outside in the snow. There is pictures of like African lions sitting in the snow and like living and giving birth there. Not only like adults can survive, but even kids. So and actually the idea, for example, with mammoth cloning. People like trying to kind of practice with the genome, but I suspect that maybe other option would be just to have a population of like Asian elephants and slowly move them towards north over the course of several generations, few generations. And I suspect that maybe in 100 years to 200 years, we will have Asian elephants like being able to survive in Chersky, just from the kind of this kind of possibility of animals to adapt to the new place.
Yeah. As a follow-up question, Michael Chang says, I know this is a follow-up about the bison and the elephants, actually. He says, I know there's really important social group behavior between generations of groups of elephants. How do you think that the absence of that social learning might affect the first mammoth or elephants introduced in Pleistocene Park? Do you have any ideas of dealing with this challenge?
We actually, so in the wild field, so in this south of Moscow park, we introduced different animals, different species, which roam together. And it was actually very surprising to see how quickly they started to remember how to interact with each other. So there are some, I'm not kind of won't go to big details. You should actually talk with my father about that. He will tell more. So it's kind of, the wild field is kind of new. Now his favorite baby. And he can talk a lot about it. So animals do remember how to interact with each other. So these strategies are basically in their genes. So they've been living for millions of years in the steppe ecosystem with lots of animals and with very probably strong hierarchy and strong social rules among animals. Mm-hmm. And they forgot about that because kind of in the modern human civilization there is place only for one species, for only, or it's say the cow or a pig, and they don't know how to deal with each other, but they quickly learn. So I believe that maybe it will be tough for the first mammoths, but I'm sure that they will kind of learn how to do it, or genetically remember how to do that.
Right. Okay, this is a question about the kind of support you need. This is Richard Perkins again. He says, Matt asks if they are tapped into the international community regarding volunteer help. Is that something you want or need?
Volunteer help. I did receive several emails from people asking for me for volunteers, but it's high Arctic, it's Russia, it's very remote, it's kind of complicated, so it's even hard to get there, and I would have to kind of, for every work I have to arrange, even for kind of Russian person, I have to do lots of things to kind of allow him to work well and kind of live normally, kind of keep the normal lifestyle in the park and kind of in the station. So it's probably will kind of create more problem for me than help. So I don't know. Mm-hmm. With just volunteers in the park, there isn't that much work. So we try to create wild ecosystem. So idea is to have as little of our personal impact into the park as possible. So
nice.
If someone will volunteer and if someone will knock at my door in the morning and said, "Oh, I volunteered to bring you the herd of bison," there they are. I would be that kind of volunteering. I would be totally supportive of.
Would you say otherwise, Nikita, the best way to help is to donate cash? That funds are the easiest way to contribute right now?
No, well, as I said, easiest would be if someone will bring me the bison to the park, because donating cash would mean that I would have to bring the bison, and that's actually like everybody is congratulating me already with the Kickstarter success, but it's we plan to bring bison to the park, and collecting money for that was just the first little step. And now I will spend at least 2 months and then like bring bison to the park and adapt them to the park. So we just made the first step, collecting like enough money for me to buy them. And there is lots of kind of challenges and risks ahead on bringing them. And I'm kind of like, that will be like quite extreme trip. So next couple months will be kind of very complicated and serious challenge for me and for our team. So it's kind of, I am not saying hooray yet. I will say, yes, we did it, let's say, when we kind of bring animals in and when they will survive the winter. And they adapt well. So that's kind of like my work just started. So yes, bakers, their work is almost done. Like in 10 hours, they will kind of celebrate the success. My success is different.
Nice. So if someone offered to, let's say, if someone had shipping connections in the U.S., say in Alaska, how would they get those animals over to you? Let's say they have access to oxen or megafauna in Alaska. How do they get those over to you?
I think like there is. We actually last couple of days we started kind of investigating into that situation. Yeah, it would be nice to have some. There is some like shipping companies, like if someone's having connections there and can help somehow, that would be great. That's for sure.
There you go. If anybody has connections to American, let's say, park rangers or shipping companies that might be interested in this project, please let us know. I'll forward this information to Nikita. So there's a few more questions, but really, again, I wanted to. I gotta say, this. As soon as I saw this last week, it was about at $70,000, and I was like, no, this has to succeed. I have to get involved in this. So I was like, I gotta do what I gotta do. I pledged $1,200 towards the Kickstarter, even though it's a lot. I can't afford, but I was like, this has to succeed. I think this is one of the most beautiful visions and something worth carrying out across generations. I know a lot of you are doing amazing work in your own continents, and Nikita, I hope we can all support you right now in this moment when you need it.
Yeah, thanks. Great. Yeah, sorry, the second minute. I will have to catch the flight, so I will have to leave in about maybe five minutes. So.
Okay, yeah. 5 minutes. You got it. And if anybody donates, just take a screenshot, and we'll tally the totals later. Yeah. Oh shoot, there's a bunch of extra questions, but it's all good. Nikita, anything else you want to impart us with?
I don't know. Like I think I already was talking for an hour. I think people are tired.
Okay. Yeah. Enjoy your flight. It's 3 a.m. Was it 4 a.m. over there? Jeez.
Yeah, it's 4 a.m. here. Yeah, my flight is in about an hour and a half, so I still have to get to airport. Yeah.
Alright,
yeah. Thanks, guys. It was a great pleasure having you. Thanks for all the words of support. It's actually the thing. Probably I would want to say that Pleistocene Park never went easy. It was like lots of challenges, lots of expenses, and lots of emotional and physical suffers. So we did challenge kind of lots of things, and not everything always went well. So it's like lots of failures already kind of trying to create that over the last 20 years. And for us, for me personally, I would say that was actually quite important to know that there are people in the world who support and think that our idea is good and it might work. And it's kind of was a motivation for us to keep going. So thank you everybody for all the words of support. I actually expected way more negative reactions and kind of negative comments when we started the campaign, and I was actually very it was very nice to hear so many people and see so many people supporting and kind of sharing ideas and saying kind of good things about the park and the work we do. That actually does mean a lot to us. So I want to thank everybody. So yeah.
Thank you, Nikita.
If someone has more questions, you can just like mail them. So my email is available. Someone if having questions, I will try to answer. Not promise I will do quick, but I will try. Okay, thank you very much. Okay, bye guys.
Thank you, Nikita. Safe travels.
If you click leave webinar, he'll be able to leave, and we'll hang on for a little bit and answer some more questions.
Okay, thank you.
All right.
Thank
awesome.
you, Nikita. Safe travels.
Thanks so much. And again, for folks, we will include Nikita's email in the replay. And that's powerful. What do you think? I
think we need to adopt a bison.
We need to adopt a bison. Yeah. Well, we're about. I know through our network we've already got we raised about at least 1,500, including the donations we've made. Yeah. So if any of you folks, again, even if you donate as little as $150 or even less, the highest number, you're gonna get a cool prize. So just donate what you can afford. I think it's just awesome. It's really cool.
Yeah, but if you do want to take advantage of the additional stuff that Raleigh and I are offering, you've got to take a screenshot and let us know that you've done it, because Nikita isn't going to track this on his own. That's
we'll track it.
We're asking him to do. So we'll track it. But Nikita did say that if we raise enough to adopt a bison, that we get to name it.
Oh yeah, we've already raised enough to name a reindeer. And we're going to let you guys decide the name, but we want to adopt a bison. How cool
would that be? We want to adopt a bison. That's what we want to do.
So John says he has a question. So does SDMC subscription let you download the webinar videos? Yes, you get access to everything.
Yeah, that's what
you can download. You can stream. You can do whatever you want, and it's a whole year. And we do this at least once a week. So you're just going to get more and more and more as the year goes on. There's so much cool stuff. Richard Perkins was on here. He has one of the most awesome. I got so much respect, Richard. Thanks for showing up, because he's dealing with high climate, cold climate permaculture and doing it profitable farming in Norway was one of the highest regulations, and he did a marathon 3-hour webinar with us that people got a lot out of.
Yep.
Okay.
So, that subscription is all our previous webinars plus the following year.
Yeah. Michael says, can we name the bison McBison Face? Oh, you got it. We can name it whatever we want.
If we adopt a bison, we will have names submitted to me and Raleigh, and then I don't know if we'll raffle it or we'll vote on it. Maybe we'll all have to vote on it. But McBison Face sounds great. I like that name. Raleigh wants to name the bison Byron Joel.
I think Byron Joel, because Byron Joel, we wanted him to get on the webinar, but he's been very elusive, so we wanted to name him, have a placard with a buffalo with Byron Joel's name on it, and then send it to him. Yeah. Or it could be Ariel Greenwood or Tom Cruise, whatever.
That's right. Are we going to turn off the recording now? Let's turn off the recording.
Yeah, we'll turn off the recording. Trying to think if there's anything else. Okay, we're stopping the recording.